What about an addition formula for tan, i.e. what is tan A plus B? It's a bit long, but we can use the sine and cosine addition formulae. So tan A plus B is sine A plus B over cosine A plus B, just from the definition of tan. And we can then expand out the sine A plus B to get sine A cosine B plus cosine A sine B. And then on the bottom we've got cosine A cosine B minus sine A sine B, just from the cosine addition formulae. Okay, what we do next is divide top and bottom by cosine A cosine B. Okay, so if we do stuff to the top and the bottom, then it makes no difference to the equalities, so we can write down an equality here. And now what we can see is that we've got, let's take in that first term in the top left corner, sine A cosine B over cosine A cosine B. You can see that the cosines there should cancel, and we should end up with sine A over cosine A. And that's just tan A. So we go to the next line, you can see I've got a tan A there. And then if we look at the next term, it's cosine A sine B over cosine A cosine B. So therefore the cosine A's will cancel, and we end up with sine B over cosine B. And that's just tan B. So you can see in that last equation there that we've got a tan A plus tan B on top. On the bottom, we have a similar sort of thing. We've got cosine A cosine B over cosine A cosine B. Well, that's just going to be 1. And then we subtract sine A sine B over cosine A cosine B. Well, we've got sine A over cos A and sine B over cos B, so that's tan A tan B. So there we go. Now, once we have the sine squared x plus cosine squared x equals 1 equation and the sine and cosine addition formulae, then we don't need to memorize any of the double angle formulae. First, we just let A equal B in the addition formulae. From the sine formula we get sine A plus B equals sine A cos B plus cosine A sine B. And then letting B equal A, we end up with sine A plus A equals sine A cosine A plus cosine A sine A. Okay, so that's sine 2A equals 2 sine A cos A. And that's one of the standard double angle formulae. Now let's do the same for the cosine A plus B formula. Cosine A plus B is cosine A cosine B minus sine A sine B. Put in B equals A, we end up with cosine A plus A is cosine A minus sine A sine A. So that gives us cosine 2A equals cosine squared A minus sine squared A. So that's another one of the double angle formulae. However, with this one, we can do a bit more because we've got cosine squareds and sine squared. So we can change this using the sine squared cosine squared equation. And we'll get 2 more equations out of this. So first of all, we can remove the cos in the right-hand side. So cosine 2A equals cos squared A minus sine squared A. Replace that cos squared A with 1 minus sine squared A, which is we can do because sine squared A plus cosine squared A is equal to 1. Okay, now we just gather together terms and we end up with 1 minus 2 sine squared A. So that's the another double angle formula. Now let's remove the sine in cosine 2A equals cosine squared A minus sine squared A, like so. So cosine 2A is cosine squared A minus sine squared A. And then replace the sine squared A with 1 minus cos squared A. Gather together the terms, we end up with 2 cosine squared A minus 1. Okay, and in a similar way we can deduce triple angle formulae, for example, by using sine 3A equals sine 2A plus A and the sine addition formula. We can also get the half angle formulae from the double angle formulae. Just let x equal theta over 2 in the double angle formula. I'll leave these for you to explore. Okay, now we've treated the standard identities. Let's look at some non-standard ones. For example, show that tan x plus cosine x over sine x equals 2 cosec 2x. Now here's a top tip for doing maths. When showing an equation is true, pick the complicated side and change it into the other side. Don't start off with taking the equation and then altering it until you end up with something which is true, because sometimes that can lead you to false conclusions. So the left-hand side in this case looks most complicated. It has an addition, and the tan is sine x over cos x, and that's similar to the second term in the left-hand side, so presumably some simplification may be possible. We find that tan x plus cos x over sine x is equal to sine x over cos x, just from the definition of tan, and we add on the cosine x over sine x. And if we take a common denominator, cosine x, sine x, we find that we end up with sine squared x plus cosine squared x, which is good because we know that's equal to 1 from our fundamental memorized equation. So we end up with 1 over cosine x sine x. And that bit on the bottom, cosine x sine x, is good because it looks like one of the double angle formula that we saw earlier. But in that case, we needed a 2. So we would prefer to have 2 cosine x sine x. Well, that's easy. We'll put a 2 on the bottom and get a 2 on the top, so that we end up with 2 over 2 cosine x sine x. And now we can use the double angle formula. And we'll just use 2 over sine 2x to get 2 cosec 2x. Okay, let's do another example. Show that sec squared x minus cosec squared x is equal to tan squared x minus cot squared x. In this case, both sides look equally complicated. So we just pick one side at random. First, we'll do this assuming that we know all the standard identities, the ones we've seen already today. And in a minute, we'll do it using only the basic ones. Taking the left-hand side, we get sec squared x minus cosec squared x equals 1 plus tan squared x minus cosec squared x, just using the standard identity sec squared x equals 1 plus tan squared x. Okay, so we get tan squared x plus 1 minus cosec squared x, and we can replace that 1 minus cosec squared x using a standard identity because 1 plus cot squared x is equal to cosec squared x, so therefore 1 minus cosec squared x is equal to minus cot squared x. Okay, so we get the equation we were trying to find. Now let's do this a different way. I'll show that I only need to know the basic definitions and identities to prove that equation. Taking the left-hand side, sec squared x minus cosec squared x, we can just apply the definition of sec, which is 1 over cos x, and we'll square that, and then apply the definition of cosec, which is 1 over sine x, and we can square that, and we end up with 1 over cosine squared x minus 1 over sine squared x. Now where do we go from here? Well, we need to know, we need to get tan squared x somewhere. So how do we get that? Well, tan x is sine over cosine, so it would be great if in that very first part of the expression it had a sine squared. We don't have that, but because we've got a 1, we know we can replace that with sine squared x plus cosine squared x. So let's do that, and we end up with sine squared x plus cosine squared x over cosine squared x. Do it for the other term, we end up with sine squared x plus cosine squared x over sine squared x. And now we end up with sine squared x over cosine squared x plus 1 minus 1 plus cosine squared x over sine squared x. So now we can see that we do get our tan squared x coming from the sine squared x and cosine squared x. And then we've got cosine squared x over sine squared x. Well, that's just 1 over tan squared x. And then the 1's cancel because it's 1 minus 1. But what is 1 over tan squared x? It's cotangent squared x. So we do end up with tan squared x minus cotangent squared x. Hopefully, this video will show you that all you need when dealing with trigonometric functions are the basic definitions of sine, cosine, tan, cosec, sec, and cot, and the equations sine squared x plus cosine squared x equals 1. The addition formula, sine a plus b, is sine a cosine b plus cosine a sine b. And the addition formula, cosine a plus b equals cosine a cosine b plus sine a sine b. Okay. Thanks for watching.